Hello. This is a quick video to show you how to do the independent samples t-test using SPSS. That's the first assignment that we have for the results section. I'm going to share my screen with you. And we are going to go to this assignment. So this is the first example. This is the independent samples t-test assignment. And this is the data that we have. What we're going to use. I have placed the data in Excel because I imagine most students will put their data, collect their data, and have it organized in Excel or some other spreadsheet before they put it into SPSS. For these assignments, you're more than welcome to put it directly into SPSS. In fact, it probably will save you a little bit of time. But I wanted to show you how to do this because I think this is the way you're going to do it for your dissertation. So we got a very small data set. We've got it organized by men and women and their corresponding heights. And we're going to open up SPSS. You got to be a little patient. Maybe a lot patient. So this is what you're going to see. A blank spreadsheet, no variables, no data. So I'm going to go to the File button. I want to import some data, and the data that I want to import is in Excel. And I have put it on my desktop, which means it's right here, independent samples t-test. So if I do that, excuse me, it's going to give me some options. By default, I just leave these alone. But occasionally you have your data and you don't have labels and so forth, so you can decide how much of the data and whether or not it has variables and so forth. But I did have a variable for each one, or a label for each variable. So I'm just going to leave it alone. And I'm just going to hit OK. So now my data is in SPSS. Unfortunately, it's in the wrong format. So SPSS, unless you're doing a repeated measures type of analysis, always wants each variable by itself, which means I need a variable for sex and I need a variable for height. So you can switch back and forth between data view and variable view. And if you just click a variable, double click it, it's going to automatically bring you to the data view so you can, or variable view, so you can add another variable. All right, when you're in this view, make sure that you've got your variables labeled correctly. I typically keep my labels as numeric, even when they're not. So I could have kept sex and I could have typed it in as string data. In other words, letters. But I'll show you why I prefer numeric in another video. But this is not as important. It's only important if you start trying to type in a, let's say, a W. It's going to say I can't do that because that's string variable, and I've got it as scale data or numerical data. All right. Now, it is important to go to the measure. And when you import data, it's probably going to say, I don't know what the scale of your data is. You're going to have to tell SPSS, because this is very important. If you give it the wrong scale, it may prevent you from doing a certain test. And if you give it a scale that it doesn't belong, you may run a test and it makes no sense. So sex, male and female, is nominal. There's no order to it. There's no amount that makes one better or worse. But for height, there is. And so height, I'm going to call scale. That's what SPSS refers to, interval or ratio, numerical data. For sex, since I'm calling a categorical data, but I'm giving it numerical values, I want to click on label and tell the SPSS what those labels are. I can make them anything that I want, but by default, I usually just stick with 1s and 2s. And so I'm going to call 1 a male and 2 female. I could have made females 1 and males 2, or males 0 and females 1. It doesn't matter. It truly doesn't. So now I've got a label. So I'm gonna go back to data view, and I've got 1 for males, and I've got 10 of those, and 2 for females, and I've got 10 of those. And then for height, I'm gonna save a little time and just cut and paste. Cut and paste. So now we've got our new format. This is the format that SPSS likes. It does not like this format. Other programs will use this format. I think if you used Excel to do this problem, this format would be fine. But this is the way SPSS likes the data. So the first thing I can do, in fact, most of the things you will need to do can be found under the Analyze button. So I'm going to click Analyze, and I've got several ways that I can get some summary statistics. So if you go back to the assignment, the very first thing that it reports is means and standard deviations for men and women. So how do I get these values and these values? So we'll go to Excel, SPSS, do Analyze. I want to compare means. I could go here and do it separately, but this is actually easier when you want summary statistics for 2 or more means. And so click means, and I want some summary statistics for height. And I want to divide that by men and women. So I want the height descriptives for men and women. So I need to put height as my dependent variable. My independent variable is 6. You click options, you can ask for specific descriptive statistics. But for this example, I just asked you for the mean and the standard deviation. So I'm just going to leave it alone. And you can change the style. Bootstrapping is not part of this class, so you don't have to worry about it. You just click OK. And just like that, we get our means and standard deviation. 69.8, 2.04. 69.8, 2.04. So that's how I got some basic descriptives. And of course, my sample size was 10 for each. If I go back to Excel, I will see my sample size, of course, was 10 for each. One thing that I failed to mention is that when I go back to my data, I didn't take the time to screen my data. And I didn't do that because I've got such small data and I've already tested it. But I recommend when you're working on your dissertation, make sure you go through your data. Look for outliers, look for missing data, look for mislabeled data. Sometimes I type a 0 or a O instead of a 0 or vice versa. Sometimes I forget the decimal and I could have 680. So it's worth the extra time to screen your data and look for these outliers, look for missing data, look for mislabeled data. So I do recommend that. The next thing that you will see in the report is the Shapiro-Wilks values. We're testing for normality. So use the independent samples t-test. We have to assume that our data for each variable, men and women, is approximately normally distributed. And there's a test for that. And I think I made a typo right here. I think I put an extra 9 in there. I think it should be 9.5 instead of 9.95, but we'll find out in just a second. Well, I think I did. So let's go back to SPSS and figure out how we get the Shapiro-Wilks. So every test that you run, or possibly could run, if it's parametric, and we prefer parametric because they typically have more statistical power, they usually have some assumptions. And so you need to test for those assumptions. You can't just dump in some data and say, I'm going to start chugging along with my analysis. You have to make sure your data meets the criteria for the analysis that you want to run. And if it doesn't, then there's alternatives, non-parametric tests that you can employ. And so an important assumption is, one, we need to have the right kind of data. And clearly with height, I've got interval ratio data, I've got scale data. And I want to know if it's fairly normally distributed for both males and females. So I can go to Analyze, and I believe this one's under the Explore button right here. And I'm going to put height here and 6 here. And so I want to test height for both men and women. And I'm going to choose the plots and make sure I choose normality plots. This will actually give me the test and some plots along with it, but I don't really care about the stem and leaf for now. So click continue, and I will get, with some patience, again, I get the means and standard deviations and so forth if you need it. But I get the Shapiro-Wilks for the men and women. And in both cases, the results are not statistically significant at the 0.05 level, which is what I want. I don't want it to be statistically significant. If it is, if it's less than 0.05, that means I probably violated this assumption of normality, and I may need to choose a more conservative non-parametric test. But in this case, I haven't, and I can tell you already I did make a typo. The value is 9.5, and I think I entered 9.95. And the women should be 9.6. Back to SPSS, and the women is 9.6. I made another typo. It's 9.62, and I put 9.61. All right. So that's how I got the Shapiro-Wilks. The next thing you will see is, go back to my data, is the actual results. Right. So this is the independent samples t-test. This is how it's reported. I got a measure of effect size, and we did a Levene's test to see if the assumption of homogeneity of variances was met. We don't actually have to do a separate test for this because the independent sample t-test typically runs both for us. With the homogeneity of variance, it's another requirement. Basically, it assumes that the variances for both of my groups are fairly similar. If they're off by a little bit, no problem. But if the variance for men is 500 and the variance for women is 50, you've got a problem. You've violated this assumption, and you probably need to choose a more conservative test. So let's see how we get this last section. So I'm going back to SPSS, and I want to go to Analyze. I can do this one of two ways, but I recommend going to the Compare Means button because it will automatically tell you, here's the independent sample t-test. I could run a general linear model and univariate, and it would give me an F value, and the results would be the same, but this is the simpler of the options. So I'm going to choose independent sample t-test. And I have a test variable, which is height, and my grouping variable is sex. And it's going to give you 2 question marks, and it's going to say, okay, out of this, it doesn't know how many levels you have. We know there's only 2. We put in 1s and 2s. You have to tell SPSS which levels you want to look at. And you think, well, we only have 2, it should automatically do it, but it doesn't. So we have to tell them. So I've already done it before, so it's got a 1 and 2 in there already, but I would type in a 1 and a 2. Those are my 2 groups because I've got 1s and 2s. If you call these 0s and 1s, then you would call it 0 and 1. And make sure this effect size is checked off. This is where we get Cohen's D. And you can click options, but I don't think there's anything that we need in the options. So the first thing that we see is Levene's test for equality of variances. And we see that it is not statistically significant, which is good because we don't want to violate this assumption. We want the 2 groups to have fairly similar standard deviations variances. And so we get an F value of 321. So we come back, assuming I haven't made another mistake in entering the data, and that's where we got the 321. And it is not statistically significant. The value is greater than 0.05, which, for better or worse, is our traditional cutoff value. So we can safely assume we haven't violated that assumption. Where do we get the D? This is a measure of effect size. And this is actually considered a large effect size. And if you go down to module 7 and so forth, you will see a discussion on effect sizes. So reporting p-values without reporting some measure of effect size is silly. It doesn't do us any good to say, hey, our results were statistically significant, but the effect, the impact that you are going to receive is so small it has no practical real world impact. So p-values should always be accompanied by effect sizes when you're doing statistical tests. And Cohen's d is one of the most common. And so how did we get that? When we chose effect sizes, it was reported. So here's my t-value. We got a 3.735. We could round that 374 if we wanted, with 18 degrees of freedom. And we're going to use this one instead of this one because we assumed the variances are equal, because we did not have a statistically significant outcome here. If this value were less than 0.05, I would have chosen the more conservative option that gives us a smaller degrees of freedom. But in this case, we didn't receive a significant Levene's F, so we're safe to use this one. And so we get a t-value of 3.7, 18 degrees of freedom, which is just n minus 1 for each of my groups. So 10 minus 1 plus 10 minus 1. And we get a one-sided and a two-sided p-value. We are going to choose the one-sided because we made a directional prediction. We are predicting that men in my scenario are on average taller than men. So an independent samples t-test was conducted to test the directional or one-tailed hypothesis that men are taller. So that's why we've chosen the one-sided. Two-sided would be a non-directional, where we say, hey, are we looking for a difference between men and women with creativity? We say, well, I don't have any reason to assume one group is more creative than the other, so I would do a two-sided or non-directional. But in this case, we clearly predicted men would be taller than women, so we're going to go for the one-sided. So I got a t-value of 0.37. So when we look at our results, we should see a t-value of 327 or 337. Probability less than 0.01. Then we got some figures and tables. This table is easily created. You can go back to SPSS and look for more information or ask for more information by going to crosstabs, compare means. And where we had this already, we can just ask for maybe kurtosis, something else, whatever variables you choose, and we will get a nice little table as soon as it's done. So here's our table. The one that you may need a little bit more help with is the graphs. And so you can find all the graphs you want right here. I typically choose legacy dialogues. And so for the assignment, I ask you for bar chart for male and female. So if I go to graphs, legacy dialogues, and choose bar chart, simple. And that's how I got this guy. So I got height is what I'm interested in, and my categories are sex. And you can ask for additional things such as display error bars. You can choose standard error, confidence intervals. It's up to you. And then hit OK. And that's how I got the chart that I got. Typically, you don't report color, and so you can just double click it and you can do all kinds of neat things. I can click this little guy and get some labels or values, put right in the middle. I can click inside these and change the color. So if I don't like blue, I can choose a different color if I want. But typically you won't see color. So that's why I reported in my example, I just turned it to black and white. For your assignment, I don't care if you give me color, but I don't think your dissertation will accept color. It gets too expensive to print. That's it. I hope that helps. And I will try to do another video for the next assignment.